Hi everyone, this is Pratik Kamasani, and today I'm going to talk about how I'm using semantic links and semantic labs in Microsoft Fabric. It's evening in UK, so light is a bit flashy, so just bear with me. So the scenario that I'm using here with semantic links and semantic labs is documentation. So I came across this use case a while back ever since I wanted to do a blog or a video about it. What I'm interested in is I want to document a workspace or a set of workspaces that I give. So it's a common use case that we work with most of the project. Okay, when you're working on a project, most of the times your interest is either on your production workspace, like you're interested to document what's happening in your production workspace, or if you're working on a project you're probably interested in a set of workspaces, especially like if you're working in Fabric and you are working for a medallion architecture kind of way, and your data is going to through various workspaces during the data life cycle, then you're probably interested to document only those workspaces unless you are a tenant admin. I don't think anyone wants to really document the entire workspaces to see what's happening in these workspaces. So that's my use case. And another thing that I wanted to do as part of this is I want this solution to be as dynamic as possible. So what I mean by that is I want to have a notebook. And when I execute my notebook should take this workspace or set of workspaces as an input, and then it should automatically go and create the lakehouse for me, all the tables with the workspaces inventory for me, and it nicely should create the delta tables so that they are available for me to do the further analytics that I wanted to do on this workspace data. So that's my use case, and let's see how I'm going to do it. So here is my notebook that I've already created. I have various sections in it. Let's ignore the cleanup section. I will come back to that a bit later. But the first things are importing the libraries and the modules. So here I'm importing all the libraries that I need. I don't really need semantic link anymore because it automatically comes with the notebook. But I was using in the Visual Studio Code, and I kind of installed most of the things that I needed, and I'm installing the other modules that I'm using in the notebook. So the first things first is define the items needed for the documentation. So as I mentioned, I wanted this notebook, the solution, to be as dynamic as possible. So for that reason, what I'm doing is first I am defining the lake houses that I wanted to use for the creation. I just realized I clicked on the play, the execute option. Um, so what I'm doing here is I am defining the lake house name and the lake house description that I want my lake house to have. So that's basically what's happening there. And in the next code cell, there's a few things happening in here. So the first thing that what I'm doing is I am getting the workspace details. So I'm using semantic link, and I'm getting the current workspace ID and also workspace name, which I would be using further down to get more information about, to create new lake houses and things like that, which as you could see in the next step. And the next step, what I'm doing is I'm checking if the lake house already exists or not. If it doesn't exist, create it. So this is also an important step for me, is because like a if I'm running this code the very first time, it's okay, it creates a lake house. But if I'm running this code like in 3 months again, then what I want is I don't want to overwrite the existing inventory I have about the workspace. What I want to do is I want to append data to that workspace. So just solely for that purpose, what I'm doing is I'm checking if the lakehouse already exists. If it exists, then it would use that lakehouse. If not, it's going to create the lakehouse for me. The next thing that I'm doing is I'm using MS Spark Utils, and I am mounting the lake house I just created, or the lake house that already exists, to this notebook. So, and I'm also getting the path for the local path and ABFS path, because I will be using this path to save my Delta tables to this lake house so I could do my analytics on it. So that's kind of what's going on in this step, is like a defining all the items that's needed. And then, as you could see in the output, well, it's basically talking about showing my workspaces and the paths and things. Not really sure how good it is to show all that information, but it's okay. And the next space, what I'm doing here is, this is where I am giving my lake houses. So you could like a in here I'm just giving one, I'm giving blank list of workspaces. We could probably parameterize these things and use it in a pipeline or something as well, but here it's just a text. So what I have here is, I have a list, and that is where I would probably, if I'm working with multiple workspaces, then that's where probably I give my workspace IDs with the comma separated workspace IDs to work with it. If I give it as a blank, then it would use the current workspace ID where this notebook is running, and works with that. So in this case, I'm interested in the current workspace. So that's what's happening here. It's using the current workspace, and it's going to iterate through the only one workspace in the next code of the block. So here, the next step is, so now I created all the items that I need. I'm also supplying the workspace that I'm working with. So next piece I'm interested in is getting the information about all the items in the workspace. So for that, I really love this single line of code from Semantic Link, which is like just literally one curve, tiny piece of code, which takes the current workspace name as a parameter if you want. Is what it's doing is, so actually there's a few things happening here. So one is it's there is a loop going on here. So if I have more than one workspace, it's going to iterate through that loop. And then I'm using this command to get everything in that selected workspace. So it gives me all the items that's available in that workspace. And in the next piece of code, I am basically transforming the column names. Of course, in the lake house, it doesn't take any spaces or any spaces basically, or special characters. So what I'm doing is, I'm replacing all the spaces and the special characters by using that one. So that's happening in the next space. And then whatever the data I've got, I am saving that as a Spark data frame, and then I am putting that, I'm naming by using that to table name, and I'm using ABFS path to save that into the lake house that I created in the previous cells. So this piece of code that you see here is, we could use semantic labs. I was actually talking to Michael Kowalski, and he was saying, like, I could just use save to Delta semantic lab, a little function, and then it saves a lot of time, a lot of bit of code. But I kind of left it like this because it was easy to copy and paste from my previous code. So that's kind of what's going on there. So if I quickly go and show you how the data looks in my lake house. So I was looking at fabric all items. And the other thing that I was also doing is, if you notice here, I am prefixing my table with R underscore. So I'm not using any lakehouse schemas. They are available to use. Instead of using lakehouse schemas, I am basically prefixing my table with R underscore. So then it is easy for me to figure out that that was my raw table. So if you look at this, as you could see, there are so many types of data, item types in here. So just to make my life a bit easy later, what I'm doing is, I am actually creating another data frame, which is basically giving me a list of um, the unique list of fabric all item types. So this is the kind of pattern that I use for most of the rest of the notebook. So what I'm doing is I'm using a function, go and retrieve the data, and if there are various types, then I'm getting the unique list of those types and keeping this data as in raw format in a delta table. And on top of that, I am also adding a load date to just so that that's didn't do how I wanted. But yeah, I'm just adding a load date as a column just so that I could go back to my raw data to see when was the last time this row got inserted and things like that. So that's kind of what's happening over here. And I'm creating the fabric items. And then right after that, I'm also creating the presentation layer for those fabric items. So everyone wants to do it differently. I'm choosing to do everything in one notebook, and also I'm choosing to do it right after I created the raw items because it's a very small solution. But you could choose how you wanted to do it. And here, there's not a lot happening here. There's only things that's kind of mostly happening is over here. Is what I'm doing is I am making sure I'm getting only unique data, and then I am also like dropping the column load date. I don't need it for my analytics purposes. I do want it if I want to go back and see when was the row inserted and things like that, especially when I want to use the SQL endpoint view. So that's why I'm doing it. And I'm creating the presentation layer for both um, all items and also item types for both of them. So in this case, I started with my first step, which is getting the inventory of entire fabric items. So that's done. The next thing that I'm interested in is lake houses. So as I mentioned, what I'm interested in is I want to know where my lake houses are, how many tables are there, and also the size and other information that I could find about lake houses. So for that, again, there are various ways you could do it. You could use Semantic Labs and get the list of lake houses, but instead of that, what I'm doing here is I'm just using the data frame I created previously, which has all the items. I'm filtering that to get only the lake houses. So now I have the lake houses here. And the next thing is I want to get the tables in the lake house. For that, I am using Semantic Labs function get lakehouse tables. So when I execute that function, it gives me the data of it gives me information about my tables and also location. So if I use this function, and I can also do it extended version of it, which gives me more information about my tables, the size, how many tables are, how many files are there, and also the sizes and things like that. But for that, what you need is that lake house has to be attached to this notebook. But in my case, I'm not interested in one lake house, but I'm interested in multiple lake houses. So for that reason, instead of using the extended version of this function, at least for now, instead of using the extended version of this function, what I'm going to do is I'm just going to use, without using the extended true, and just get list of the tables by using this function, and then use other functions to get more details about my tables. So this is an example about how the data looks like. So in the next step, what I'm going to do is I'm actually going to, because I have multiple lake houses to work with, I'm going to iterate through all those lake houses, very similar to what I've done previously. So what's going on here is, first I am iterating through all the lake houses here, and then I'm using this Empire Labs and getting the lake house tables of all those lake houses. Then I am basically keeping that into a pandas data frame, and at the end I'm appending it to the data pandas data frame. And finally, I'm keeping that into r underscore lakehouse tables, again by using the same ABFS path that I've used previously. So that's basically what's happening here. So, and now what I would have is I have all my lake houses and all the tables and also the location of each of those tables, which helps me to get the details of those lake houses. So, however, what I have here is I also have a lot of tables as well. So especially I have this one where I'm using the weather data, and weather data is something where I'm getting, this is another open data set thing that I'm working with, is it's gets all the weather information from various locations, and it's a lot of tables. So I don't want to run this whole code on everything. Instead, I'm more interested to just get a subset of lake houses just for the sake of it. So for that, what I'm doing is I'm basically filtering, grouping, and filtering out to get only the workspace, or sorry, only the lake houses which has 5 or less than 5 tables in it. So I have nice, good sample, good set of data to work with. So that's basically what's happening there. So in this code cell, what I'm doing is again very similar to the previous approaches. I have list of items. I'm going to iterate through it. I'm going to use Senpai Labs and get the data and then put the data into a Delta table in my lakehouse. So if we just go into it, so this is where the iteration is happening. This is where I'm running the extracting the data, and there is a bit of error handling is happening over here. And then this is the important information is I am actually using Delta table detail functionality to able to extract more data, more information from the for that Delta table that I'm working with. So as I mentioned, I want to know number of files I have, the size of the Delta table, size of the file, and things like that. So by using this piece of code, I could get that information. So that's basically what's happening there. I will show you the data in a sec. And then I am also adding some extra columns so that it is easy for me to understand which lake house the data belongs to and which table that lake data belongs to. And the rest of the things are very similar. It doesn't really need error handling here. But what's happening here is I'm just keeping the data into a lake house. So as you could see, it has created it's printed quite a few lines, but what it's doing is it's iterating through those tables and saying the data has been inserted or created in that location. So if I go here and show you the tables, there you go. As you could see, it's nice to see, like, because I have R in front of it, I could quite quickly figure it out where the data is. So these are my lakehouse tables, and as you could see, it gives a nice bit of information. It tells me various functionality. It also tells me, like, how many files are there, the size in bytes. It is quite interesting, and you could also see the number of files I have and stuff like that. So going back to our code, one of the nice functionality is a shortcut is escape O, and then it nicely it hides your output. And if you could click escape O again, and then it shows the output. I really like that shortcut. So next one is I am creating the presentation layer for my lakehouse, which is similar to what we've done previously. I'm not prefixing with the R anymore. I'm just using the normal naming conventions here. There are a few reasons for it. One is because it's simple solution, so I don't need more naming conventions. I could just use that one because there is only one user who will be accessing it, and I know that user understand what I'm doing here. The another reason is I'm u- I'm using the Vertipack analyzer, and there I don't have the control of what to name, how to name my tables, and that's why I decided just to keep the consistency, not to include another prefix for these tables. Otherwise, I would usually prefix with the p underscore, so it's like a presentation layer. And when it comes to my Power BI model, that's where I would rename, um, in my semantic model, that's where I would remove the p underscore and things like that. But again, it depends, changes from solution to solution, and also depends upon the team that you're working with. So going back to notebook, what we have, the next item that I'm interested in, next artifact, is the semantic models. So when it comes to semantic models, you could make it as complicated as you want. Especially because semantic models data is very rich. There is so much information there. You could get from the model name all the way to the row level information by using various functionalities. But here I don't want it to make it that complicated, so I'm more interested in just getting an understanding of my semantic models, the tables, the columns, measures, and the sizes of the models that I am working with, which would be useful when I'm especially working towards performances, things like that. So for that, what I'm doing is, again, very similar approach. I'm using the similar way where I am filtering based on my item type. But there is one other thing that I'm doing which is important here. Is, let me actually close the table of contents so we could see. I'm also filtering the report usage metrics model. Because I don't have the access to the underlying semantic model, it throws an error if I don't filter it out. So for that reason, I'm just filtering those things out. And the rest of the things are very similar to what I'm doing with the everything else. I have I'm basically extracting the data, renaming the column names, adding the any necessary columns I needed, and then keeping that data into same ABFS path that I've used. And I'm using the similar naming convention to save the data. Again, here also I have various object types in my semantic models. So that's why I'm creating one more table where I have my object types. So that's kind of what's going on over here. And again, I have a lot of print statements, which I'm going to hide them by using my new favorite shortcut, Escape O. And and the next thing is I'm creating the presentation layer, which is again very similar to what we've done previously, and just I've to not maintain the consistency, I'm writing code a tiny bit different. Instead of giving the table name, now I'm actually using it in the path itself. But as you could see, I don't have p underscore anymore. So that's kind of where I created the data I needed for Lakehouse tables, and I also created a data I have for semantic models. But to know more about the inside, what's happening in the models, sizes, and things like that, that is where semantic labs, it's the best. It's because instead of going and running various tools and installing them and all those things, I could just use the notebook, I could use the semantic labs, and I could run a Vertipack analyzer, or I could run I was going to say bits helper, not bits helper. I could run best practices analyzer, and then I could get all the good information about my models, which would be useful to especially improve the performance or to just understanding what's going on your models. And also, they're really nice, especially if you are working on what's happening in your models, how if you are somebody who's faces with the performance issues, then it's probably a very nice way to just track how your models are working. Or for example, you have a production workspace and you are admin of the production workspace, and you want to make sure you have all the models which are created according to the best practices, then you could just run best practice as analyzer, and you could also even see how the models has been changed over the time by tracking that information. So you could do various things by with that. But in this case, I'm not doing all those things. What I'm doing is I'm basically just running the Vertipack analyzer to get the data about all my semantic models into a table. So you may have noticed I skipped a code cell here. So why is when I'm working with when I'm working with Vertipack analyzer, and when I want to keep the data into a delta table. So in this case, what I'm using is it's a really simple one-line statement. I am running the Vertipack analyzer. I'm giving the data set name, workspace name, but I'm also giving the export to table. So what that does, it automatically exports my data, my output into various delta tables. But that happens only when you have a lakehouse attached to your notebook. If there is no lakehouse attached to it, then it doesn't work. Just for that reason, I'm actually attaching the lakehouse to my notebook, and so that it when it runs, it nicely saves those Vertipack tables into my lakehouse. But if that is not something that you want, and you want to actually manually create various tables, for example, what's happening here is as let me go back here and let me show you how we get data. So this is our semantic model objects data. And as you could see, there are various types of objects. So if I'm just focusing on tables, and if I do it, as you could see, like within one workspace name, there are various data sets, and just for the table, I have a lot of data. So if I don't want to use Vertipack Analyzer, and if I want to go and create all these various tables manually, well, not really manually, without using Semantic Labs, then I could use this one. So this is going to that table, finding out object type, and it's basically churning all the tables based upon various object type. And then you could use REST API and get more information, like DMVs kind of information, basically what Vertipack Analyzer does. You could go and do that by using code as well. But I was not interested in that. I rather just go and use Vertipack Analyzer and get my data into the lakehouse that I wanted to get into. So now I have all the data that I need. I have the data for my lakehouses, and I also have the data that I needed for my semantic models. And as you could see, there is a lot of output. So now what I'm going to do is I'm going to create a new semantic model. So instead of using the default semantic model, I prefer using the new semantic model. I actually prefer to actually use it in the Power BI desktop. Um, but now we have everything in the service. It has its own pros. So I'm going to name it semantic model document. Just say doc, because I have another one called documentation, and I have a document. So let's just call it doc. So what I'm interested in is I'm interested in Fabric all items and item types, interested in lakehouse tables, not interested in any of ours, interested in semantic model object types, objects, models, and I am missing all my Vertipack analyzer tables. And that's the thing I'm not a huge fan is like if you don't know what you're looking, sometimes you don't see them. See, and then if you know what you're looking, then you could go and search, and there they are. So I have few Vertipack analyzer data. So I'm going to confirm, and that's going to bring that data into my semantic model in the service. So it's here. So I personally prefer to just create new layouts. So in this layout, what I'm interested in is I'm going to get fabric item types, and then I'm going to get my semantic model information. Then I'm also going to get so dataset ID to dataset ID. Same goes to other ones. So now I have a data set with the relationships looking pretty okay. I wouldn't call it's all the good relationships because Vertipack Analyzer tables needs further changes because obviously a column connected to the data set, it doesn't really make that much sense. But anyways, I want to maximize this and it's not letting me over there. And if I just do a drill down, it's kind of shows me a view of all the items that I have in my thing. So that's good. Next thing, I'm probably interested in my lake houses. So let me get my lake houses. And I just realized I have the lake house tables, but I don't have my lake houses. So if I go back to my here and edit tables, no, I haven't created lake house table detail table. So I'm just going to rerun the entire thing. So this is where this piece is going to come really useful because it's going to clean up and rerun the whole thing. So now if I go back here and click refresh, I should have lakehouse tables, which has the data about my lake houses and the table information. And then if I go to lakehouse table details, this is where I would have more information like a number of files and everything. And I go back to my Power BI, click refresh. And I said if I go to my lakehouse data, lakehouse table details. So I'll also create the relationship. And if I go back here, do the refresh, I have my lakehouse name and I also could see, well, that looks like I have some duplicates there, but for now, I'm just going to ignore that phase and just showcase how I could see all the lake houses and also all the tables underneath that. Next thing I'm also interested in is semantic model information. So for example, I'm interested in a semantic model. And then I'm also interested in the tables under each of those semantic models. So if I just probably create a new page and I create a semantic model as a slicer. So I'm going to change that into a slicer and I have my semantic model as a slicer there. Next thing I want to do is I'm just going to create a table. So I'm going to keep the semantic model name and then I want to keep the number of the tables information. So I have a table name here. I haven't created the relationship, so if I go back here. Okay, so I'm going to use the dataset name and I'm interested in the table names. Probably again, I'm going to change that into like this. And then I'm interested in the number of columns it has and the number of partitions, hierarchy size, dataset size, row count, basically all the information I could potentially get. And as you could see, I have a lot of information here, and probably just focus on something I know, which actually has some data. Probably use InvenFX. Yeah, that's a good one. Then I could see all the tables and all the information I have underneath it. Of course, it needs a lot of modeling, tidying up the relationship, but it shows how I'm using semantic links in Semantic Labs to document my workspaces. Bye.